So the subject, let me introduce the subject itself. The subject full name is Technical Drawing with the Fundamentals of Descriptive Geometry. Okay, it's a mix of subjects. It's a mix of 2-3 subjects that you will take in the further your program. Okay, so the first is Technical Drawing. Just you can study. You will study in this subject how to draw correctly, how to organize everything with the product or construction or building. And descriptive geometry is the basics of the drawing. So that is kind of theoretical knowledge is also included into this course. Technical drawing, drafting, or drawing is the act and discipline of composing drawings that visually communicate how something functions or constructed. There are two things: how something functions, and second thing is how something or some product or some vehicle, how is constructed. Okay, so if something, if some description of how that thing is functioning, or how this structure or vehicle or thing is constructed, if you see these informations, so that will be a technical drawing. Okay, that will be a drafting, that will be a drawing. So objective of the study, the objective of the technical drawing. The objective of the technical drawing is a standard representation of an object to create. Okay, so there is a way of representation. So there is a rules of representation. Otherwise, if you invent something, so you can draw by your own way, and others may not understand what you draw. Okay, so that's why kind of the style of drawing. There is a style of writing, right? Writing style. So similar of this, there are drawing style. So and the styles should be kind of standardized. Okay, so there is a rules, there is a standard. So you have to follow, everyone to follow this one. Otherwise, other engineers, other users, other professionals may not understand what you draw. Okay, so that's why there is a standards, and the objective of the technical drawing is the standard representation, to follow these standards and to study these standards. Okay, so we have to understand, we have to study these things. So objective of the subject of technical drawing is to study to improve these standards. The technical drawing is essential for communicating ideas in industry and engineering. Okay, not other places. Like I cannot go to the medical doctors and show my drawings. No, we are using in this area. Okay, so in this area, in area of industrial design, industrial manufacturing. Okay, industry, the construction, construction building constructions, and engineering itself. Okay, so it's wide area of engineering. There is a lot of mechanical engineering, aerospace engineering, biotechnical engineering, medical engineering. There are a lot of engineering sphere. Okay, so we are using technical drawing in this area. And to make the drawings easier to understand, people use familiar symbols. Okay, so we use symbols that everyone can understand, or everyone can use that symbols. Perspectives, units of measurement. So okay, so we're noting like, okay, we are using only millimeter, or we are using only inches. So and then everyone use that units of measurement. Notation systems. Okay, so have to represent, there is a rules, visual styles, and page layout. Okay, So this kind of the rules we have to follow, and we are studying in engineering drawing this kind of thing, okay? in technical drawing. So together, such conventions constitute a visual language. There is a language types, visual language, and help to ensure that the drawing is unambiguous and relatively easy to understand. So in next slides, I will show this. Okay, so there is a language types. Many of symbols and principles of technical drawing are codified in international standard called ISO 128. Okay, so there are a lot of standards, but there is an international standard also, that is ISO 128. It includes symbols and principles of technical drawing. What kind of symbols we have to use, what kind of principles. So we are learning this kind of things. And so graphic language, the graphic language. What's the meaning of graphic language? Before understanding what's a graphic language, I have a question for you. So can you see on the right hand side the part is shown here. The gray part is shown here, and try to write a description of this object. How you describe this one? For example, by phone. So you're talking into the phone, or talking with your friend in the phone, and you're seeing only this. You're only seeing this part, but other side on the phone not seeing this object. Only you are seeing this object, and how you are describing, how you give a description of this part to your friend by phone. So you are saying, you might say, okay, so this is a gray part, and the size is almost 15 centimeter, and the weight is somehow 300 grams. You are saying like, okay, so material is looks like aluminium or steel. We don't know. And there are some holes, 3 holes. Okay, 2 holes are similar and 1 hole is bigger. And what else? So there are 3 sides are round shape, and some corners. It has some 2 corners, cylindric areas, and with hole from 2 sides. And from the top, there are 2 holes, similar holes, smaller 2 holes. That's only, right? So to describe this one literally by your own words is very difficult. So you cannot transfer the information by using your world language, your own literal language, okay? And the other side, by using your words, cannot generate this one 100% similar to this, okay? So he will generate something differently. So he may imagine the thing very differently. Okay, so it might be generated this object very different way. So to provide efficient representation, efficient translating, efficient interpretation of this one, description of this one to other side, we are using a graphic language. If you put a picture here, so then if you send this picture by Telegram or by graphically by email, okay, the other side may understand very easily and very perfectly. So that is a graphic language. Okay, so otherwise, if you have no graphical language, to describe this one is very, very difficult. Okay, so that's why we need a kind of graphic language. And that graphic language, to make this graphic language or to use that graphic language, we have some rules. You can easily understand the world language are inadequate, cannot describe 100% the size, shape, and features. Okay, to give the size exactly is difficult using world language. The shape, you cannot describe shape like this shape to other side. It's very difficult. And features, there is a features like the mechanical features, physical features, some material types. So those kind of features. And graphic language. Graphic language is an engineering application use lines to represent the surface, edge, and contours. So here you can see that on left-hand side, 3D representation of the right-hand side object. Okay, right-hand side object is given like this, the picture. But if you have this kind of the drawing, only sides are shown here, and inside features are not shown, but only the edges are shown with using lines, and you are understanding by this one this right-hand side thing. Okay, so we are describing of this thing by using 3 views or many views, and only edges are shown, and the holes are shown with only in the edges, and the contours. Okay, so outer contour is shown, and there is some lines that shows that the center of the hole or symmetricity center. Okay, so this kind of thing, the language is known as a drawing or drafting. Okay, so graphic language type of this is called drawing or drafting. And a drawing can be done using freehand, instrumental type, or computer method. There is a types. There is a types. Drawing can be done using freehand, instrument, by using instruments, or computer methods. So let's see what are they. So freehand drawing, usually we call that one sketching. In some references, in some books, it's called sketching or just freehand drawing. So you are using a drawing, you are using a to draw without using any ruler. Just you are using hand and a pencil or pen. The lines are sketched without using instruments other than pencils and erasers. Okay, so it looks like something like this. It's not straight. It's not very perfect, but it gives you the information about the part. So this part, so you can understand this part by using these 2 views. So that will give you the chance to understand how it's constructed, how it looks like. But why we are using this? Why we are using this? Why we are using this kind of freehand drawing? Okay, so we are using freehand drawing when we have no time to draw very exact, very precise drawings. So because as you know, to draw very quality drawing, it needs a time. But when you have no time, no place, no desk, no lighting, no very comfortable place to draw, so just on hand, you are drawing freehand with using free hands in some standing position, and just showing to your friend or to the engineer your idea. Okay, usually we are using this one in the shop floor, in the factory. Okay, factory shop floor line. There are dark area. It might be dark area. It might be noisy area. It might be no place there, no desk. Okay, so on the standing position, just you draw in the piece of paper, just freehandly, or you are sketching this one and showing. Okay, so we are using in this time. Okay, very fast, but it gives an information, but it's not precise. It's not looks very good sometimes. So this one is an instrument drawing. You're using instruments like a ruler, protractor, or a compass. Okay, so automatic pencil, pen. Okay, instruments are used to draw straight lines, very good straight lines, circles, and curves concisely and accurately. So the drawing are usually made to the scale. We're using a scaling. Okay, so you can measure this one, and you are able to know, you understand what's the size of it. Okay, so it's very good. There you can see the dimensions also. You're seeing the line types are very good shown, like dash line, center lines, contour lines, okay, continuous. So third one, the computer drawing. The computer drawing we are usually made by commercial software using computer software and computers in order to generate this kind of drawings. Okay, it might be two-dimensional and three-dimensional. Okay? It might be two-dimensional drawing or three-dimensional assembly, three-dimensional drawing. Okay, so and what's a good points of this? What's the advantage of this one from others? So from the freehand drawing and this one, what's the difference? The difference is to make this one sometimes needs more time than freehand drawing. But if once you do this one, you can share this 100 times. You can copy and paste, copy and send, and also it's more safe. More safe. You cannot delete it. You cannot lose it. Once you do this one, it might be saved in the server. Might be saved in the in some server, and so you can draw back this one. Okay. So and what's the difference of 3D and 2D? In 2D we can see only from one side, from one plane, but in 3D we can see from many sides. We can understand the clashes. So one part is clashing to other side, or one part is there is a gap between two parts. Okay, so those kind of problems by third dimension you can see it. Okay, mostly the buildings are drawn in two-dimensionally before the long time ago, like 10 years, 15 years ago, 5 years ago. They used two-dimensional drawings to draw the building. So there was a problem when they build a building. Some of elements of construction might be clashed after some level of the building. Okay, so some of the after building some levels, 2, 3 communications are intersected each other, and they clashed, and then at that time it were needed to change their design drawings, and everything should be done again. So that is a lot of difficulties might occur. Okay, so to prevent this one, if you do this one in 3D, you can see in real before doing in real product or real construction, you can see your product in the computer, and you can solve your problem, and then after solving your problem you can make it. So then you will have less problems, less difficulties. Okay, so that's why 3D is very important. To generate 3D very important, but it's not easy such two-dimensional to draw this one. It's more difficult to do the 3D. It's difficult, but it's very useful, and it's very efficient. And what's the difference? In 3D, you can add the highlights. Okay, you can add the color. You can add some material type. You can add some shading. Okay, so you can add some the light source, like you can change the light source and the shading will change. So those kind of information, it looks like reality. Okay? So you can get the mass total weight of this. So design process in whole product life cycle. So did you understand these 3 types? Okay, so if you are going to be an engineer, so you have to try 3 of them, and you have to be a master to drawing 3 of them. Okay, and then you have to know, you have to understand what's the difference and what's the good points and bad points of them. Okay, so now let's see the design process in whole product life cycle. What's the life cycle is, and what's the product, why we need to study product, why we need a design, why we need a design process, why we need to understand what the design process, where is the position of design process. Okay, so drawing. So this kind of drawings, like technical drawing, why we need this one? Why we need this? So we need technical drawing in order to construct something, in order to make something, okay, in order to build something. And secondly, we need to improve something. We already have some product. We have already the building. We have already some automobile, car. How to improve this one? In order to improve this one, we need to have its drawings, and then we can change it, okay? And then we can generate, we can produce the second version of it. Okay, so the third thing, third one, okay, the first one is design and made it. The second one is improve it, what you have already. The third one is to save it, save some information. After some time, this building might be destroyed. After some time, that car might not be available. But if you have a drawing, so you might reproduce this one, remade it, remanufacture it after 100 years later. Okay. And the fourth one is to share with others. Okay, so you can share your product with others. You can sell it. You can sell, for example, our cars is sold by other companies like American or Korean companies sell the product package to us, and then we are going to produce. We are producing some parts of them, and some are not. Some are we purchasing from other countries. Okay, so if you have a product design package, so you can sell it. So and okay, so the product is very important in the in every stage of engineering. So engineers are the person who is producing a product, who is building a construction. Okay, so the construction also a product, or doing some service. For example, they carry some containers, carry some kind of the loads by using some the sea or some car ways. Okay, so highways. So they're using some trucks for them. So engineers are doing producing, improving that products, or making a service to take from one point to the second point that products. Okay, so this, for example, in the sea ships, you can see that ships also the product of the engineer's job. Okay, so as you know, that we are working with product, so there is a product development. So there is a life cycle from starting of the planning, designing, up to the manufacturing and supplying and supporting. So it's all are connected to each other and starts again everything. Just like for example, this one of the first stage is planning. So you're planning why we need this one, why we need this product, and how to improve this product, or how to make this product to sell in order to purchase from other side, from other country, can we produce ourselves? So those kind of planning, how much we have to produce this one, or how to sell this one, what will be our profit. So then after planning, the styling, artistic design will turn on. Artistic designers drawing the shape of this. Okay, so artistic design, this is not a technical drawing. After this time, so designers, so mechanical designers, so the product designers, that is the engineers. So this is artist, okay, so that is engineer using this artistic shape, this kind of design. So they are designing a parts of this, and they're designing in the computer, in the 3D or in the 2D computer with size, with the sizes and with the material type. And then they're simulating before building, before making it. Okay, so simulating and solving the problems with some with size. Okay, so if some fuel is not passing through some channel, some tube, so they're increasing the tube size, like diameter. They might increase or reduce. They're changing. They might change the material type. So these kind of simulations should be done. And after this one, tooling. In order to make this part or this product, so it consists from many parts. So each part should be produced. How to produce this one? With using a tools, okay, like stamps, dies, okay, some molds. Okay, so there is a they have to design that molds and dies to produce this, and then machining of these tools and some parts of it. So machining process take a turn on. And after this one, assembly. Okay, so you did many parts, but you have to assemble it. So assembly also a process, also a very huge process. And then robotics. If you use the robots in your manufacturing place, so so robots, you have to draw the code for robots. You have to solve the robots way of using this one in the manufacturing plant. And then plant design. So you cannot put everything without having very good planning. So otherwise you will have the problem. So that's why it's a planning of the plant is very important. So you have to reduce your product cost. So you have to plan very well in the plant. So, and quality checking. After manufacturing something, you have to check this one. Is it correct or not? Is it under the required standard or not? For example, you're producing 10 centimeter something, but it's not 10 centimeter, is more than 10 centimeter or less than 10 centimeter. So you have to check this one. You have to measure it, okay, and then check, is it okay or not? So that is a quality. And then production. So in this stage, you have to calculate everything, every stage cost. Okay, so it's price of this every stages, and then the cost of workers and those kind of things, cost of material, cost of the plant, cost of manufacturing process. So those kind of costs, and then you are generating the cost of product. Okay, so and then you are getting a price of the product. So then you can supply it, you can sell it. Okay, you can sell. You can for example, in cars, you are selling to the dealers. You are giving this one to sell to the to people. So and then they are selling. After sometimes, if the people have some problem with the product, so you have to support them. You have to support. Okay, so you have to change the wheels. You have to change some oil. Okay, replace the oil. You have to repair it if they have some problem. And then so they will give some feedback. Okay, so the wheels are very hard. We have to change. You have to change before selling it. Okay, so they're complaining to the manufacturer, and then so they're giving some feedback, and then that feedback should be used in the planning for next stage. Okay, so this kind of cycle. Okay, so cycle rotates again. So they're changing. They're doing different design. They're doing engineering design. Okay, inside of it. This cycle is rotating many times, and then in order to get very good, very efficient product. Okay, and so this should be like this, but it's not like this. Okay, in reality it's not like this smoothly rotates, but theoretically it should be. Okay, theoretically in ideal case it should rotates like this, so then you will get very good product. Otherwise your product will not be good as you need. So why I'm showing this one to you. So so you're going to be an engineer, so that's why I'm showing as stages of the product development. Okay, so you're going soon later, after 4 years, you have to go in some area in some of this stage area. Okay, so for example, some of you might be a mechanical engineer. You're going to the mechanical design, or mechanical designers, engineers might work with robotics or plant design. Some of them, some of you might go to the supply and sell the cars. Some of you might be a machining engineer. Some of you might go to the assembly shop floor. And so from now on, you have to prepare yourself where you are going to from these items. Okay, so and you have to prepare yourself in each of these stages. Each of these stages has own drawing types. Okay, documentations. Each of these stages has own documentations. So that documentations, you have to understand that documentation, and mostly they have drawings. Okay, so technical drawings. 80%.
Professor,
Yes.
in which part of the circle the technical drawing was used? In the design part?
Everyone, no. Each of them has used technical drawings.
Ah,
Okay?
technical drawing. Okay.
Each of them. I will show later on. Okay. I will show later on which items. Okay, which sphere or which stage has what kind of documentation. Okay. In
I have one
next.
question, Professor,
Yes.
again.
Yes.
For example, if we are studying in an IT course of this Turin Polytechnical University,
Yes.
and after graduating from the university, in which part of the circle will work? In all of them?
No.
In IT course, I meant.
Yes. Okay. So you're studying in our university. The purpose of the opening the IT field in our university is to providing IT professionals who is working, who are able to work, and who are solving the problems of manufacturing of the automotive industry. Okay, you have to go to the Uzafto area, and you have to actually the purpose was like this. So inside of any items of Uzafto or any plant of Uzafto, so you have to solve the problem of this connection. So it's you will join these subjects. Okay, so planning, styling, design, simulating, tooling, machining. So you have to join this one, and you have to make rotating working correctly this thing. Okay, so you have to connect this one.
Okay, thanks, Professor.
You're welcome. So and you might work, for example, robotics field. It's also each of them has own IT. For example, we may not say, okay, simulation field is not related with IT. So a lot of software inside here. So you have to work with mechanical engineer together to solve some problem. So you will install the products and to help to solve the problem. And mechanical engineer might give you some theoretical thing or some theoretical knowledge, but you're giving a from technical support side of IT support, like install the software and seeing the results, or sharing results with other part. Okay, for example, production, they have to calculate a lot of databases there should work. So you have to work with database, and so this one you have we have to understand. Okay, but still, so this chart, okay, this picture I'm showing every year, but still within 5-10 years, still we are not cannot work this one very perfectly. It's not connected yet. So okay, next slide. Design process. So what's the design process? So initially there will be a specification. What's a specification? I will show on next lectures. Okay, so specification is the rules. Okay, so it should be something like this. Let's speak with example. Let's speak with example. This example, like the car example. Like specification can be like the car should work with the gasoline number 18. Okay, so that is a specification. If you design the engine works with gasoline 18, AI18, Saxon. Okay, so your car should work. If you specify, okay, the gasoline number 95, so your car will be different. Okay, so your engine will be different. So this kind of thing. Or we are using the car, for example, another specification. We are using the cars for the carry the load. Okay, so for example, like a truck. So that will be truck. If you use another specification, okay, so this car is for everyday using, for family using. So that the car will be some kind of Orlando type. If you say, okay, so we need the price. Okay, so price should be less than $5,000. So then your car will be kind of Matisse type. Okay, so specification, the rules come from the planning area, and then initial design should be done. Okay, initial design is just the design. There's a couple of designs. So 3-4 types of design should be done here. Initial design, like you're drawing freehandly, artistic design, or just some several concepts. You are doing the concept here, and then your evaluation process. Evaluation means like you're checking, is it okay or not? Check with this given specification. Is it not expensive like is shown before? Like is enough cheaper than $5,000, or is more expensive than $5,000? If yes, okay, if satisfies, design satisfy the specification, so then go to the production. Okay, produce this one. If not, so you have to modify your design, change something. Okay, buy cheaper parts inside. Okay, include cheaper parts instead of expensive one, and then so make it cheaper, and then satisfy less than $5,000, and then okay, produce it. So this kind of process. So this process, each of this process, we have technical drawing. If you do correctly, so you are making smaller cycle. Okay, smaller time. You are spending smaller time and smaller money. Time means money. Okay, so if you are doing cheaper thing, and then your company will get more profit. Otherwise, it will be very expensive product, and then so you cannot sell this one in the market, or you are selling, you're giving very high price, and you are getting less profit. Your company will get less profit, or you will get a lot of complaints from the people. Okay, so that's also not good. Like similar to this stage. Okay, so it's very expensive, but they use very cheap things. Why is expensive? Because of the process is not good. So your turn, your goal should be to make a cheaper this one later on. Okay, so every engineer should learn this one before doing your product. Okay, so now you have to understand, you have to try to understand how to make a cheaper the product, or how to satisfy the specification. For example, some people might need very good quality, so they have a lot of money, and so they need a kind of supercar, Ferrari, like Ferrari kind of car, supercar. So at that time, they're not looking to the price side. They're looking to the quality side. So that's also possible. So here you can see the chart is showing two things. The first is cost of change, and another is the green one is innovation impact. The And here you can see the stages of design. Here the time passing through. So there's a concept design, detail design, prototyping. Prototyping means they're doing some prototypes before manufacturing 1,000 types, 1,000 items. Like they're prototyping only 1, 2 items, and then they're evaluating, they're checking, is it okay or not? And then production. That is a mass production. 1,000 parts might be produced, 1,000 products might be produced, like in the factory. So that is a stages, okay, stages of the product design. And here the cost, okay, so in advance the cost is very small, like 1x. Just put the into the x $1,000. So $1,000 you can design in the computer. That's your product. And in the detail design, so part designs inside of each part should be designed. But here is just design, you know, just auto design of your car. But here all parts should be designed. So $10,000, you're spending $10,000. And prototyping. In the prototyping, so you're making this one like one item, one prototype. So you're making. So you're making like printout in 3D printer, or you're making yourself something. It's prototype. Okay, so in exhibitions you are seeing mostly prototypes are shown. It's not in real product. It's just prototype. It's kind of to showing this one how it looks like later on when they build. And then evaluation. So that needs this $100,000. And production, mass production. This one is factory production, size 1 million. Okay, so innovation impact. So as you go far from the starting of the design, so you cannot change itself your product anymore. Okay, so for example, the cost of change. Okay, so cost of change will increase if you go far from through starting of the product. So you can change very less thing at the end of. Why? Because if you change here, so you have to pay everything again. You have to go design and change detail design, prototyping, everything. So okay, so in the starting stage, you have to make your idea very perfect. Your idea should be very well here thought. Okay, so your idea should be managed very good here. When you at the end of saying, at the end of production, you shouldn't change anymore. So when you change, you have to pay very, very big money. So cost of change very big here. Okay, why? Because you have to pay previous stages also. So if you make very good design in concept stage, so you can go very smoothly and there are no problems, and then you are paying less. So your product will be small, the smaller price, has a smaller price. Okay, that's a problem. How to do this one? How to do this? How to do this? So by using a computer, okay, or by using IT technologies, by the using of very good, powerful software. Okay, if you do not have this one, so you are doing drawings with some error. So you are making here some drawings here, and in detail design you will have problems. Some of them are clashes, some of them are, you know, might not work correctly. So you are going back, you're changing it, you are paying again. Okay, so time is passing, so you're paying the salary every month. So, paying, changing, so paying more. So your product price will rise up, will be expensive. So you cannot sell this very expensive car in the market, while, you know, Chinese car are very $5,000. You can get SUVs. We cannot compete then. Okay? So to compete this, we have to reduce the price. How to reduce the price? You have to change yourself. You have to improve your design in advance before manufacture it. Okay, so how to do this one? So you have to use very powerful computers. You have to use powerful software. Okay, so to understand this one, to use this one, we have to learn technical drawing rules and also modern technologies of technical drawing. That is a CAD software.